Question 6. Calculate the midpoint Riemann sum asked for below to estimate the area under the curve f of x equals the integral 3x squared plus 1 on the interval 0 to 6 using 6 subintervals of equal length. The first thing that I'm going to do is draw an interval chart. I'm going from 0 to 6. I have 6 spaces to cover, and I have 6 subintervals, which means I need to go by ones. Okay, and since I'm going by equal intervals to get the Riemann sum, I'm going to put a 1 on the outside because that is what I'm going by. And then I need the midpoints, which means on this one that between 0 and 1, 0.5 is my midpoint, so I'll do f of 0.5 plus between 1 and 2, 1.5 is the midpoint, so I'll find f of 1.5, and then between 2 and 3, 2.5 is the midpoint, and then between 3 and 4, 3.5 is the midpoint, and then between 4 and 5, 4.5 is the midpoint, and then between 5 and 6, 5.5 is the midpoint. Okay, so now I will calculate that, and I will use my calculator to help me out with that, and when I do that I should get 220.5. Number 7, refer to the position equation S of t, a sprinter's distance from the starting line during the first 4 seconds of a race, as defined by the function S of t equals negative 8t over t minus 5. Set up an integral and find the average velocity of the runner during the first 4 seconds of the race. All right, first thing, key thing I see is average velocity. So as soon as I see the word average, I know it's going to be 1 over b minus a times the integral from a to b of f. Okay, so this one's going to be 1 over during the first 4 seconds, so it would be from 4 to 0. And then 0 to 4, and then it said average velocity. So I need a velocity formula right here. Okay, so this is going to be 1/4 times the integral from 0 to 4 of velocity. All right, I've got a couple choices here. I'm going to kind of explain the long choice, but then I'm going to choose the faster choice. If I need velocity and I'm at position, I'd actually need to take the derivative of the position formula and plug it in there. I'd have to use the quotient rule, and then we could work it out, right? Somebody noticed as they were working these problems, I could actually take a little shortcut because the integral of velocity is going to give me position, and then we can calculate it at 4 and 0. So I could actually, to find this answer, I could find s of 4 minus s of 0, and then when I'm done doing that, I can multiply by 1/4. So that's definitely the direction I'm going to take. So if I plug 4 in to the s equation, I end up getting, let's see, if I plug 4 in there, I'm going to get negative 32 over negative 1, so I end up getting 32. So this is going to be 1/4 32 minus, if I plug 0 in, I'm going to get 0. So that will just simply give me 1/4 times 32, which is 8. And it said the average velocity, so velocity would be measured in meters per second. Problem 8. Use the trapezoidal rule with n equals 4 to approximate the integral from 2 to 3 of 1 over x minus 1 squared dx. All right, first thing I like to do is let's go from 2 to 3, and we have n equals 4. So if I'm covering just one space, 3 minus 2 is 1, and I need to split it into 4 parts, I'm going to go by 0.25s or 1/4. So this will be 2.25, 2.5, 2.75, and then 3. Okay, with the trapezoidal rule, I like to use the actual formula 1/2 height, sum of the bases pretty much. Okay, so I'm going to do 1/2. The height would be what I'm going by. I'm going by 1/4 or 0.75. And then on my insides, I'm going to do f of the first, so f of 2. And then if you recall for the trapezoidal rule, we're going to multiply the insides by 2. So I'll do 2f of 2.25 plus 2f of 2.5 plus 2f of 2.75, and then plus f of 3. Notice we don't have to multiply the last one by 2. And then from here, I'm just going to let my calculator do all the work for me, and I should get 0.509 as my final answer. Okay, number 9, moving on to non-calculator problems now. Find the x values of all relative extrema of the function y equals x cubed minus 3x plus 1. Also, find the intervals on which the function is increasing and or decreasing, and justify your answers. Okay, so it looks like we have all sorts of stuff dealing with y prime. So I am going to find y prime. Y prime will be 3x squared minus 3. And next thing I would like to do is find the critical numbers. So I will set the derivative equal to 0. If I do that, I'm just going through and solving for x. I will get x equals plus or minus 1. So if I do a y prime chart, put negative 1 on it and 1 on it. If I plug in negative 2 into y prime, I will get a positive value. If I plug 0 into y prime, I will get a negative answer. And if I plug 1 or 2 in, I will get a positive answer, and I'm plugging it into y prime. So that gives me enough to go for it. It says find all relative extrema. So I would say that there is a relative max at x equals negative 1, and it just does say to justify your answer. So I will say because y prime changes from positive to negative, okay, there's going to be a relative min at x equals 1, and that will be because y prime changes from negative to positive. All right, and then there I will say where y is increasing. So y is increasing on the intervals negative infinity to negative 1, and then from 1 to infinity, and that would be because y prime is positive. And then y is decreasing on the interval just negative 1 to 1, and that is because y prime is negative. Please notice I did use y this time and y prime instead of f because they were talking about y instead of f. Number 10, discuss the concavity of the function y equals x minus sine x on the interval 0 to 2 pi. Also, find the x coordinates of all points of inflection of the function. Justify your answer. Right? If we're talking about concavity and points of inflection, I know I need to get 2y double prime. So first the first derivative would be 1 minus cosine x. The second derivative is going to equal positive sine x. So getting a critical number, I will set sine x equal to 0. I know that happens at 0 and pi and 2 pi, and I won't go farther than that because my interval does not go farther, so I am going to make myself a y double prime chart. 0, pi, 2 pi. If I plug in pi over 2 into that first derivative, the sine of pi over 2 is equal to 1, so that's going to be a positive value. And then if I plug in 3/2 pi, the sine of 3/2 pi is negative, so that will be a negative value. And then from here, we are first of all going to find all coordinates of points of inflection. Well, there is a point of inflection at x equals pi, and that will be because y double prime changes sign, and we don't care how it changes, just as long as it changes. And then it did say to discuss the concavity, so I will say y is concave up on the interval 0 to pi. Notice I didn't have it go from negative infinity to pi because we were given endpoints. And this will be because y double prime is positive, and y is concave down on the interval pi to 2 pi, and that is because y double prime is negative. And please notice again, I was referring to y and y prime and y double prime instead of f because they're talking about y in the equation.